This lesson is find the formula for XYZ in terms of ABC. Here is an example with 2 by 2 times another 2 by 2 matrix equal a 2 by 2 matrix. So when you multiply matrices, make sure the inner number of the dimension are the same. Okay, so this is a 2 by 2, this is a 2 by 2, so we can multiply. The inner number must be the same. Okay, so we just multiply. So first row, first column, which is here. First row, second column, which is here. Second row, first column, which is here. Second row, second column, which is here. Okay, so AI, which is here, plus BX, which is here. A0 plus BY, which is here. Next, CI, which is here, plus 0x, which is here. Next, C0 is here, plus 0y, which is here. Okay, now I is just an identity, so anything times to the identity is go back to itself. So think of I is 1, so A times 1 is back to A. Okay, so that's what I is. I is an identity. So think of it as 1. A times 1 is back to itself, or anything times the identity is back to itself. Okay, so A times I is A, BX, this gives me 0, that leaves me BY, CI is just C, that's 0, this is 0, this is 0, so the whole thing is 0. Okay, next we need to match them by the terms. Okay, so A plus BX is equal to this 0, which is here. BY equal to I, which is here. C equals Z, which is here. 0 equals 0, which is here. So we just match the term up. Okay. Next, we need to find out what they are. So if you look carefully, C equals Z, this is already done, so there's no solving. Next, we have BY equal I, so BY equal I. Now, if B and Y are square matrix, that means they have the same dimension, then B is invertible. So we can bring the B over to the right side and becomes the inverse. And that is based on the invertible matrix theorem. Okay, so it has to be a square. So B and Y must be a square. That means it has the same dimension, 2 by 2, 3 by 3, 4 by 4. That's what square means, 2 by 2, 3 by 3, 4 by 4, and so on. If that's the case, then based on the invertible matrix, there is that B has an inverse. Okay, so Y is equal to B inverse. Same thing with 3. So the part 3, I have A plus BX equals 0. So if I solve for BX, bring the A over, I get negative A. And we do know that B has an inverse, so we just multiply the inverse on both sides from the left, and here from the left, and here from the left to both sides. Inverse and itself will disappear. All I have left is just X. And then this B inverse times negative A will give me negative B inverse A. So there's my formula for X in terms of AB, Y in terms of B, and C in terms of Z. And that's what we are looking for the formula for X, Y, Z in terms of A, B, and C. Okay, so just like what is asked on the front top, it says find the formula for X, Y, Z in terms of A, B, C. So here is our formula. C is Z, Y is inverse B, X is minus inverse B times A.